Hello, my name is Laura Gomez-Rey, and this is my Physics 2211 lab report on torques. Alright, so the goal for this lab is to utilize Newton's second law and find the torques of the experiment, and our result would be that one torque was found at the end of the system and possible errors that will happen at the end. Alright, so Newton's second law basically states F is equal to mass times acceleration, which relates to torques because we need to use the force that is applied on the system to find the actual torque. And the torque formula is basically R, the cross product of the distance of where the torque is to the pivot point and the force that is applied. And it's the distance from the center when it's centered around the center, and then R of A when it's at another point. Also, you can also do the magnitude of R times the magnitude of force times sine of theta when it's a 90-degree angle. Alright, so for our systems and surroundings, our system will be an Apple Pencil for this experiment, and the surroundings will be my hand that is putting a force and creating a torque on the system. So this is kind of a free body diagram showing what a torque looks like. So here we see the pivot point on the left and the force being applied all the way at the end, and then the distance from the pivot point from where the force is applied, which is that's what we will cross the distance with the force to find our actual torque. Alright, so here's the video that I did. Basically, it's just pushing an Apple Pencil down, and then we see the torque happening. Alright. And then here is the tracker model analysis, so we can see where the actual force is being applied and then how it's moving down, and then we see the torque actually happening. Okay. Alright, so then for the results, we see that the force is the distance from the pivot, which is 6.53 inches. The force applied was -8 newtons since it's going in the y direction. And then our actual torque is going to be, since it was 90 degrees when it started, we're going to use the magnitude of the distance and the magnitude of the force, and then sine of theta. So it's going to be 6.53 times 8 times sine of 90, which is going to give us 5.25 nm. Alright, so analysis and errors. So the tracker is not always accurate with its data points because it can kind of get messed up and not actually track it at the exact point where it's moving. Also, we didn't account for other forces that could have happened in this experiment, like air resistance, for example, like wind in the air, anything like that. And also the fixed point, which was my hand, is not the best visual of an actual fixed point because my hand could still be moving, which it did in the video as we saw. What if the force was applied at the fixed point? So if the force was applied at the pivot, there would actually be no torque because the force is being applied at the pivot point. And this means that the distance from the force and the pivot point is 0. So 0 times any force is going to give us a torque of 0. Or 0 crossed with any force is going to give you 0. And then what if the force was applied at the center? Basically, then the torque would be half of what it was, of what we got, because it's applied, of what we got at the end of the system, because it's applied only at half of the distance. So it would be less. The torque would be less. So in conclusion, a torque is the cross product of the distance of where the force is applied to the pivot point and the actual force applied. And there is no torque when force is applied at the pivot point, since the distance is 0 from the pivot point. As we see here, 0 crossed with F is going to give us 0. Thank you so much.